I ended with the promise that I will show you some methods which are used to solve the linear equations, uh, two linear equations of maximum variable 2. So that can be solved with different methods. The methods are graphical, second was substitute method, third one is eliminating method, fourth one is cross multiplication, and other two are I will not discuss, as I said, because that needs some maturity and knowledge of something which could be only be taught in higher classes, because that needs some related subject to be taught first, then after to come to that. So these two topics are, although I will not explain or discuss, but I am just naming it for the knowledge, determinants. So these are the methods by which a two linear equation of variable 2 or 3 linear equation, in this case also can solve 3 linear equation of variable 3 also I can solve, from 2 to 3 I can solve. So this I will not discuss. So for this case I will solve two equation with two variables. So this was my target. So one by one I will explain, and then I will give you some examples, numerical examples, so that you could understand. So we'll start with the graphical method. So for graphical method, you might have come across the standard graphs that is available in market, that has been arrayed or distributed in uniform cells. So if it is x-axis and y-axis, but that is not mentioned in that graph. Graph is basically a paper where this paper is uniformly distributed with unit division. These unit divisions are of 1 centimeter each in both sides. So some vertical and some horizontal uniform lines are drawn. Each of the distance is 1 centimeter either sides. So this side also in one division 1 centimeter, this also one division 1 centimeter. Now in this I assume this x and y axis by taking the mid of the point, so that equally I can distribute the page and can plot our graph. So this method needs this graph with standard graphs, where I will plot the equation that is given. So I am assuming two standard equation of universal form. This is one linear equation, and other linear equation is this is two linear equation of universal form. I am saying because I am keeping this coefficient unknown. This could be anything, and accordingly I can solve. So if these two are representing two equation, for graphical method, what I will do, for the equation 1, I will take a table which will be divided in such a way that independent by dependent variable, I will assume some value of x, and accordingly I will plot some value of y. Now you know, to draw a line I need 2 points to join. So if this line, there are 2 points I can get, then I can join the line, and I will represent this line with that joining line, because I am saying if 2 points is such that if it is known to me, I will join it and extend on any side according to the slope of the line. I can move it on either side and get this line, and from that line that line can be plotted in the xy axis. How it can be done? Let's say for this if it x is equal to 0, y will get minus c1 by b1. If x is equal to 1, say, then y is equal to how much? It will be minus a1 c1, a1 plus c1. Let me explain because I will only take 3 values, not 2. I will take 3 values for the ease of the representation or joining. So I will take 1. Let's say this will give you a1 plus c1 divided by b1. If I take 2, I will get 2a1 plus c1 by b1. So this would be the 3 values, and if I say this is x and y axis, this is x and this is y, and this is 0 0, then for x is equal to 0, my y value is somewhere in between. Let's say if c1 is less than b1, so it will be within that. Let's say is less than, so I am getting this point. This is 1, for 1 value I am getting somewhere this, and for 2 value somewhere this. So if I join this line, I will get something like that. And similarly, if I get the respective value for the second equation, x and y, I will get some value here also for the same terms. If I say 1, 2, I will get similar value, and I can represent, let's say these are something else, so I can represent this like this. So it is a practical representation, because by seeing that I can put scale there. If it is even, I don't try to get something which will be a fraction, rather get some integer. So it will be easy to plot, because integers will follow these segmental lines, otherwise fraction in between. So it will be very difficult for to present in the graph. So once you will get this, you can join the line by scale. Once you will get, you will plot the points, you will put a scale and join the 3 lines, and will get this line, and accordingly this also. So this can be once presented, I will get some value here. Okay, now this point will lie on both the lines, that I will not able to get it by putting the value. That will be a very long thought process. Rather, if I plot it in the graph and I draw a line from that one on the x-axis, and the same on the y-axis from that point, I will get 2 verticals from that intersecting point. So I can measure it by putting a scale. I can measure how much it is coming on the scale, centimeter scale, and how much on the x-axis. From that I can value, this value will be x coordinate, let's say x1, and this value, that y, this vertical is y1 value, that I can measure with a scale once it is plotted in the uniform graph, the already available graph. So we can solve it by plotting this. Once, the first things, you have to plot the points by random values, taking random values. Try to get it in integer form. That will be easy to plot, because it will follow the division, this partition lines. And this is the first precaution you have to keep. So once you draw, but during drawing, just remember, draw with a very thin nib, so that, because if line size is more than a millimeter or something, so that will cause you to get not getting the closer result. That will may be deviating from your exact result. You may fall somewhere which is very nearer but not exact. So, and the line should be a very small dot. So that must that time kind of precaution you have to keep during plotting in the graph. And your line should be so precise that it should pass to the points that you have taken as per this table, and as per these tables. So it should not, so that when you are joining lines, it passes through some nearby line. So this much deviation or deflection will give you a wrong result. So this kind of precaution you have to keep while you are using graph. So with that, when you will drop two verticals, you will get definite values of x and y, and that will be your solution. Understood? So this is the graphical method. Second one, so if I take the example of graphical method, that will be easy. Let's say x minus 2 is equal to 0, 1 linear, because I am taking one single variable rather getting two variables. Two variables also can be solved, but that will be very long. But I am to show something which is one variable. It will be easy to understand first, then I will come to the two variables. So these are the two equations. So if I plot it, in this case it is very easy because y value could be anything as I explained, but x value is 1, 2. If I take 1, 2, 3, so this will be something parallel to y axis. This first one, this is equation 1, and for this equation 2, this is 2. So other equation should be, it is non-intersective, it is parallel. Rather I will take y plus 2 is equal to 0. This is second equation. So y plus 2 is equal to 0, that means it is, if it is positive x, this is positive y, this is negative y. So this will be on the negative side of y, like that. So this will be y plus 2 is equal to 0, and this is x plus 2 is equal to 0. So y, if it is y is constant, then it will be parallel to x axis. Remember, if it is x is constant, it is parallel to y axis. So now these two lines, this is 0, 0, and now this point will meet meeting point. Now if I plot any value of x, y, it is very easier because that x will not vary for first case, x and y. Okay, so any value, now here as x value is always 2, 2, 2, y can be anything. Okay, so accordingly I get the values, and I draw the lines, this line, and I will accordingly I will get x and y for second cases. So here x can be anything, 0, 1, 2, but y will be minus 2 always. So this will be parallel to x axis. Okay, now once you will get, I have to get this. Now we can measure it, and you need not to measure because these are parallel lines, two perpendicular lines that will meet at, without seeing I can say this will be the point. So for single variable it is very easy. Now move to the two variables. Let's say if I assume something of two variables, let's say x plus, I am taking some simpler example, 1, and x minus y is equal to 1. So what would be the equation then? What would be the line then? Now x and y for first cases, if I take 0, x is equal to 0, y is equal to 1, x is equal to 1, let's say, then y is equal to 0, and x is equal to 2, let's say, then y is equal to minus 1. So let me plot this on the line. So x is equal to 0, y is equal to 1, this point, x is equal to 1, y is equal to 0, this point, x is equal to 2, 1, 2, y is equal to minus 1. So I have to go negative side, so is equal to 1. So this line, so if I join this line, I will get something, this number 1 equation. For the second equation, x and y, if I put 0, 1, 2, for 0, x is equal to 0, y is equal to minus 1, x is equal to 1, y is equal to 0, x is equal to 2, y is equal to minus 1, y is equal to 1. Okay, so now if I plot it, x is equal to 0, y is equal to minus 1 here, x is equal to 1, y is equal to 0, this point. Now you can see during plotting already I am getting this point. This would be a possibility, but not always. 2, I am getting this. So if I join it, I can see there is a common point which need not to be solved automatically during plotting. Unfortunately, I have got the solution. So if it is not the case, then if some line comes like that, you have to drop perpendicular to this, and you have to measure this part and this part. So this will be your solution. This part will say x, this part will be say y, and accordingly I will get the value in graphical representation. Okay, now coming to the next, which is substitute. Now how will you substitute? Let's say I am taking 2x plus 3y is equal to 2, one equation, and another is 3x minus 2y is equal to 4 is second equation. So I have to substitute, use the substitute method. So what would be that? If I assume if I consider the equation 1, it is 2x plus 3y is equal to 2. So from there I can say y is equal to 2 minus 2x and 3y, and y is equal to 2 minus 2x by 3. So here y can be represented in form of a function which consists of constant and x. There is no other thing coming for representing y. So y can be a single item, can be represented with a number of items. Okay, so if that can be possible, now this y can be substituted in equation 2. So y I am getting this. So substituting, my next step would be substituting y in equation 2 from 1. So this I have got from here. So I will substitute this to equation 2. So my substitution will bring this form. Y I am getting 2 minus 2x by 3 is equal to 4. Now you can see the second equation turns into one variable of x, substituting the other variable. So it will be very easier for me to calculate. Now I am rubbing the top part, which is not needed right now. So as per the rule, all variables in one side, all constant to be moved to other side. 4 by 3, sign change here. So this will be 9x plus 4, 13x by 3. Here it is 12 plus 16, 3. Now as both the denominators are same, I can cancel it out. So my remaining value is 16 by 13. So this will be my value x. Now this x value I can substitute in any of the equation. So I have taken 2x plus 3y is equal to 2, the first equation. So from into that, any of the equation you put the x value, that will give you the same value of y each cases. So any of the equation you can use. So 2x is equal to 2 into 16 by 13 plus 3y is equal to 2. Now 32 by 13 plus 3y is equal to 2. Bringing all constant in one side, sign change. This will give you 26 minus 32 by 13. So this will be equal to 6 minus 6 by 13. So y is equal to minus 2 by 13. Okay. So this is your solution. So this is the process by using of substitution method and solving two equation. Okay. Now move to the elimination method. Elimination. Okay. Now let me try some equation. Let's say 2x plus y is equal to 1 and 3x minus 2y is equal to 4. These are the two equations given. You have to solve it by elimination method. In elimination method, out of these two equations, either I can eliminate x first or y first, that is up to me. So you have to choose where you have to calculate lesser. So where the coefficient is less, if you target that, that will be easy for calculation. Here you can see out of x and y, the coefficient here is higher than y. So this is the one of the perception, but it is not always true. Okay, so you just take a choice of your own, but if you practice more, that will be easily will come to your mind which step you have to take. So to save time, these are the some tricks that can be developed of your own, not that you have to learn from somewhere. You have to make it your own. So try to keep your mind alive always when you are learning or you are doing something. So as this is my perception where the coefficient of y is lesser, so the elimination will be easier if I target to eliminate y first. Why? Because for elimination I have to multiply the equation such a way that other coefficient will be equalized. So here I am getting y with the 2 coefficient. So if I multiply it with 2, it will be equalized then easily without less of calculation. So if once it is equalized with the plus or minus between these two, I can eliminate y. So once I will multiply these two, that equation becomes 4x plus 2y is equal to 2. And one more thing, when you are multiplying with some numerical on the both sides, the equation doesn't change its characteristic. It will be same as earlier. So I will multiply the 2 to get this equation, and the rest, the second equation I will keep as it is. Now you see, you have to consider the next step in the sign. Whether you have to subtract equation, the converted equation 1 from 2, or you have to add up, it is depends on the term that you are trying to eliminate. Here you can see the term I am just trying to eliminate is 2y. So it is keeping plus here and minus here. So you need not to do subtraction, because subtraction will change the sign, rather keeping the opposite sign. So here is automatically it is opposite. So you need not to subtract further. You have to add it. So this choice also has to be made wisely and very sincerely. Just keep it in mind what function you will do. If you do plus, you just keep a plus sign here so that no confusion come. So plus sign, there will be no change of sign. All the sign will be as it is. It will be 7x. It will be 6. So x will become 6 by 7. Now the other way, the first I will get x. On the other way, the same thing, I will try to eliminate the x. Now here you can see, to equalize the coefficient, I have to reverse the factors that will change the coefficient into same term. So with the 2 and 3 I will get 6, because then in that case 2 and 3 LCM I have to consider in mind. 2 and 3 LCM is 6. So I have to bring something as 6. So I have to multiply with the reverse coefficient. Okay. So I have to multiply this 3 by 2. So then it is automatically eliminate x. So it will become 6x, 3y is equal to 3, first equation, and this will turn into 6x minus 4y is equal to 8. So here you can see that both sign of same. So I have to subtract, then only the sign will change. So it will minus, it will change its sign, it will minus, it will change its sign. All the below bottom line equation will change their sign when you will do subtraction. So this has to be very neatly or mindfully keep it in mind. Okay. Now as it is sign change, I will eliminate this. This will follow this sign, not this sign. So I will add this. So this will belong to the new sign to this term. So this will be 7y, and this will become 3 minus 8, that is equal to minus 5, because 8 is more than 3, so it will carry the highest term sign. and so which is having highest value, that sign will be carry forward. So this will be 5 by 7. So this is totally a method of elimination. Now one thing you can do, first when you have got the y value by eliminating y, x value by eliminating y, so in second term, rather doing elimination again, you can do the substitution method, the part of substitution method. So this will be a combination of elimination and substitution to avoid this further calculation. This could be a very cumbersome calculation. Sometimes it will be more value there in the coefficient. So that time it will be very tough for you to calculate. Rather, once you will get easy way the first value, then you can substitute it in one of the equation to get the second value. So that will be a combination of substitution and elimination. Okay, so this is the elimination. The next the last one is cross multiplication. So in that I will take the generalized equation a1x b1y plus c1 is equal to 0, because I have to establish some empirical formula that will be easier for students to calculate statewise, not to indulge to follow the process always. Rather, if you remember that empirical formula or the relations between the variables and the constant, it will be easy to get that in a shorter time. Okay, so this is generalized equation I am taking. So what I will do, I will use first the elimination method or substitution, whatever say, I will use the elimination method, let's say. So for eliminating, I will eliminate it y first. So to eliminate it, I will multiply it with b2, I will multiply it by b1. So this will be something like a1 b2x plus b1 b2y plus c1 b2 is equal to 0. It will convert into a2 b1 x plus b1 b2 y plus c2 b1 is equal to 0. Now you can see that y terms is equalized. I will do subtraction because all the signs are same. So here I will get a1 b2 minus a2 b1, and taking x common, y is anyway eliminated, and c1 b2 minus c2 b1 is equal to 0. Now what is the x value here? c1 minus of c1 b2 c2 b1 divided by, this will come in the denominator, a2 b1. Okay, now x value is this one. So can you say what would be the y value? In a similar fashion, if you see the similarity, you can automatically say here b2 is coming, for y it will be a2 and a1. Another thing will remain same, c2 a1, and below the denominator will be same because this is consisting of coefficient of x and y, so there is no variation in that. So you can see it. Now these are the equation, I am just rubbing it. So you can see the x value is what I am getting, c1 b2. So if I bring that below the x, c1 b2 minus c2 b1, I will get on the right hand side is minus 1 by upon a1 b2 minus a2 b1. This I am getting from this. So this part is over. Now same I am doing with y. What I will get, c1 a2 minus c2 a1 is equal to minus, the term will be same here for the constant part. There will be no change. So now you can say if this is equal to this and this is equal to this, so all three should be same. So I can say x by c1 b2 minus c2 b1 is equal to y by C1A2 minus C2A1, and minus I am dissolving inside, so I will get A2B1 minus A1B2. Only thing you have to remember the cycle of coefficient A1B2 C2B1 C1A2 C2A1, here A2B1 A1B2. So this will be an empirical relation or the standard formula, you can say, where two equation of such form is given. You can solve it by this, by cross multiplication. Means when you want to get x value, so x will be equalized with that, so you can get easily the x value and y done. So with this formula, if any equation, let's say, now I am just keeping this and just want to correlate to the equation. Let's say 2x plus 3y plus 1, 3y is equal to 1 is equal to 0, and that to 3x plus 2y plus 3 is equal to 0. Now you can see by this, from this you can say that a1 value is 2, because that was in plus formula, this is also plus formula, b1 is 3 and c1 is equal to 1, a2 is equal to 3 and b2 equal to 2 and c2 is equal to 3. So this value if I put directly x by, now c1 b2, c1 1 b2 2, so I can say 2 minus c2 b1, c2 b1 9 is equal to y by c1 a2, c1 a2 3, c2 a1 minus 6 and 1 upon a2 b1, a2 3, b1 3 9 and 1 is a1 b2, a1 b2 4. So now you can see x upon minus 7 is equal to y upon minus 3 and 1 upon 5. So it is very easy for you to solve it in once, at once. So x will be your minus 7 by 5 and y is equal to minus 3 by 5. By equalizing this I will get x, this equalizing this I will get y. So it will be in one shot you will get both the values. So this is the cross multiplication method, where you have to remember the empirical relation between, if it is such. Now some cases the equation may not be as usual like this. There may be x minus y is equal to 1 or x plus 2y is equal to 3. Now you have to remember, for this case just you have to bring it in the form as said in the theory. You have to bring it this way. How will you bring it? X coefficient is 1, here plus of minus 1 into y plus of minus 1 is equal to 1. So if you represent in this form, so here a1 is equal to 1, b1 is equal to minus 1 and c1 is equal to minus 1. So once you will do that and during calculation you consider these values, so there will be no ambiguity. So first thing you have to represent in the form of a1x plus b1y plus c1. So once you will be able to bring it in this form, then that empirical formula will also holds good for this kind of equation. But you have to keep it in mind what to do. Okay, don't forget, don't go in the same manner it is given. You will not get always in this form, rather it may be in any form. You have to convert it into that form. That you have to keep in mind. Okay, so this for today on the linear equation. In a later class I will give you some more example on linear equation and followed by the quadratic equation. Thank you.